Okay, we got another question in the discussion area. Thanks a lot, Sean. Really appreciate it. So it's section 4.5, section question 14. It says a 22 kilogram crate. All right, so here's the crate. It's 22 kilograms. That's good. Slides from rest. All right, so its initial speed is 0 right up there. Um, Down an inclined plane at 29 degrees to the horizontal. So there's theta right in here. Right in here is theta, and I've said it's 29 degrees. And it slides onto this spring. So what I've kind of drawn here is what happens when it first hits the spring, and then it compresses the spring and eventually comes to a rest position here. So if you can imagine, the object hits the spring, and then while it's in contact with the spring, it compresses the spring by 0.30 meters. So that's what I've drawn here. There's a delta x. There's a displacement while in contact with the spring. Goes from an initial x position to a final x position. Usually the rest position we call 0, and then finally it compresses it by 0.30 meters. And that's what it's done there. Okay, and it says determine the total distance the crate slides along the ramp. Friction is negligible. Oh, that was very nice of them to make friction negligible. So what I've drawn here in purple is the displacement of the crate as it slides down the ramp. At this spot right here, it would engage the spring, and then it continues to slide for a little bit and gets right there. Okay, so what have I done here? Well, I've said that right here, right here is the y initial, where the object starts at a certain height. And then right here is the y final, where the object stops. Okay, now you could use this larger triangle to try to figure this out, but what I would do to make life really simple is say, look, let's imagine this yellow triangle here. See that yellow triangle I've drawn there? It's not really there. It's not really part of the ramp, but let's imagine this yellow triangle there. And the reason I'm saying that is now the tip of the yellow triangle here is where it starts, okay? And right here is where it stops. Let's call that right there y final equals 0. So let's make our height equals 0 here. And this goes back to stuff we learned in grade 11, even this year, where we get to pick our common reference point, or where our height is 0. To make the math easier later, when I use the law of conservation of energy, I'm going to pick y is 0 right there. And I'm going to use this triangle for my investigation, for my solution. Now, if you take a look at this triangle here, it has as its hypotenuse the distance that the crate slides down. So that's also convenient right there. The distance that the crate slides down becomes the hypotenuse of this triangle. And I've drawn that here on this other diagram for further convenience. So what I'm saying now is this is my y equals 0. I'm still going to call this y initial, except now it's this side of the yellow triangle. And here's the distance that it travels. It becomes the complete hypotenuse, and that's what I've drawn here. Y initial from our new 0 up to the top, the distance that it traveled. And we still have the same angle theta in here. You probably know that since this line here and this line here are parallel, okay, and here's the common intersecting line, we would get theta in here as well. I'm sure you all know that. So there's theta. All right, so here's my y initial, which is the one side of the yellow triangle. Here's my distance that it travels, the hypotenuse of this yellow imaginary triangle that we're using to solve this. And then by understanding the trig identity, the trig ratio, that opposite over hypotenuse is sine, I get that this height, y initial, is equal to d sine theta. Right there. All right, so now, like in many of these questions, we're going to use the law of conservation of energy. And the total energy initial is equal to the total energy final. Well, the total energy initial is all gravitational. It wasn't moving, okay? And the total energy final is elastic potential energy, because it's not moving here, and here's the real savings from using the yellow triangle. this becomes height equals 0, y equals 0. That means I don't have to add a gravitational potential energy on this side of the equation. I don't need another term. There's the real savings of all we went through with creating the yellow triangle there and then understanding the trig relation. So gravitational potential energy initial, mass times gravitational field strength near the surface of the Earth times its initial height, okay, all scalars, is equal to a half times the spring constant times how much it was compressed by squared, all scalar. Now I use this relation right here. Bingo bango, I know what y initial is. It's d sine theta. I do some rearranging. And I know the spring constant. I know how much it's been compressed by. I know the mass of the object. I know what planet I'm on. I know the angle. You can all substitute in values. And bingo bango, you get the answer. Thanks so much for asking this question. I really appreciate it. And hopefully you will ask more questions and I'll be able to answer them.